Okay, so as I said here, just to kind of refresh where we're at here, we got this nice little square wave. So now we need to build a triangle wave. So we're just going to build a triangle wave here. And this is actually something we already do know how to do, based off of what we had discussed in the videos on Wednesday. So if I have a square wave, so let me just redraw my square wave. That's not a great line. Let me erase that one and try again. That's slightly better. So we have my square wave here. And I want to build a triangle wave. But let's just think about this. If I integrate this, well, if you integrate a number here, you're just going to get, just want to think here for a second here. You're just going to get a constant. And the constant, you know, is when, I'm not saying constant, when you integrate this, if this was for instance 12, and if you integrate 12, you get of course 12t. Now, without worrying about initial conditions and everything, what we really are wanting to try and eventually build here is we want this to look something like, oops, like this. Now, we're not going to ever be able to get it exactly like this because we can't get to the rails exactly. But that's what we're trying to construct, is that green curve there. So, but that's just simply integrating. You might say, how do I start at negative 12 here? Well, these are initial conditions, and even remember in this one we had this warm-up thing. So we're really not necessarily concerned about what happens within the first few milliseconds, and that's going to be important when we simulate these. The first few milliseconds are kind of irrelevant to us. It's more what happens once the thing's been powered up, and it's something we call steady state. Alright, so I just simply need to integrate. Well, we should know how to integrate. Right? What's the circuit that we have for integration? Well, minus, plus, ground it, and I'll put here V in, R in, whoops, that shouldn't be a resistor. I'm starting to write the thing, C feedback. This was an integrator, remember? We talked about this in the previous section. So that would integrate my square wave and get me exactly what I need. Now, the choice of Ri and Cf depend on the frequency or period, if you want to think of it that way, of the square wave. What do I mean by that? Well, we need this thing to, quote, integrate fast enough. We want to make sure that it actually integrates this, because if we don't integrate it fast enough, what happens instead is you'll still get a triangle wave, but if you don't choose the right values for Ri and Cf, what your triangle wave will look more like would be this blue curve instead. Which is okay. I mean, you could still make this work. But it's not as ideal. It would look more like the blue curve. That's what playing with this Ri and Cf will do. I mean, there's some other factors that it plays into, but that's the main factor of what Ri and Cf do. All right, so let's look at our circuit that we have so far. So what do we have here? Well, we have first OpAmp, Let me get back to black. We have our first OpAmp minus plus oops, that's not what the first stage is. First stage is my square wave. So I've got a resistor here, R2, R1, R, and then C. So this generates my square wave, and yeah, I know I have power on this. I'm just ignoring writing the power down for now. And then I feed this into my integrator. So CF and RI. So then out of this, we're getting a triangle wave. Now, you might not see how this triangle wave is going to help us generate a PWM signal. Believe it or not, we're almost done with getting the PWM signal generated. Let's see here how just an OpAmp works if we just put two voltages on here, minus, plus, and then I'll just say V1, V2. If V2 is greater than V1, V out is equal to plus VCC. Just saturates. Large signal voltage gain is just going to saturate it. If V1 is greater than V2, V out is going to be negative VCC, because again it's just going to saturate it. So if we use an OpAmp in this kind of configuration, we can actually use an OpAmp as, you know, an OpAmp can be used as a comparator. Well, how? Well, I'm comparing V2 and V1. If V2 is bigger than V1, I get a positive voltage out. If V1 is bigger than V2, I get a negative voltage out. So I'm literally comparing voltages. Alright, so that's actually all we're going to do to hook this up with one additional factor here. What we're going to do here is, in fact, let me just lasso this circuit here. Come on. Come with me. So we're going to take this circuit and we're going to add a comparator stage onto this. So what we're going to do here is we're going to hook this up. And I want to think just for a second here. And I just need to think for 1 second. Let me pause the video. Alright, unpause the video. I had to remember this is what I want to make the negative, and this is what I want to make the positive here. And again, these are all connected to VCC as well. And this is, I claim what's coming out here is my PWM signal. Okay, so we'll draw a graph to see exactly what's going on here, but let's see what this potentiometer here is doing. So this potentiometer here, this R3 and R4 aren't always necessary to put there, but oftentimes you need to put them there, especially if you don't have a full triangle wave out. If you don't have a full triangle wave out, like we had shown, I'll scroll back here, like something with the blue curve, for instance, as opposed to the green curve, you have to put a couple resistors there so that your comparator will operate on the region so you can get the full range of motion of your potentiometer. But that's just something you kind of have to play with when you actually build the circuits and look at the signals. So what do we get here? Well, let's draw a graph here on what's going on. And I'm going to draw probably more than one graph, but that's okay. So first off, let's just draw my square wave back in. I'll make this one 4 squares for my period. So this is the square wave off of my first stage. Then we integrated, and we'll just assume we got a nice, perfect integration here. And then what I'm going to do here, I'm running out of colors here. See here, let's do purple. And then basically I'm going to set the positive on that third stage, and I'm going to just say, for instance, I'm going to set the positive right here for the third stage. Actually, I have this backwards. I need to make one small correction on this here. It's not a big deal. I just need to make a small correction. This actually, I had it backwards. This should be minus, and then that should be plus, right? Yeah. Okay, so then what we're going to do here is I'm going to put it in a thicker green line here. So what we have to do is we're comparing the purple line and the blue line. So the triangle wave's coming in on the positive terminal, and the other thing you want to remember is that V out, remember, is your large signal voltage gain times V plus minus V minus. Okay, so if we look over here, let's look at the beginning. The purple is V minus. Let me correct that. V minus, because I did correct it over on here, but I hadn't corrected it there. So this is V minus, and this is V plus. So V plus minus V minus, that gives me, I'm sorry, V plus minus V minus. This is a negative minus a positive number, so that's going to be negative, so that's going to put me down at the bottom here. And so this is actually going to get a little too ugly. I'm going to erase my square wave out of here carefully. Okay, so triangle wave and then my V minus. When I'm in this region right here, this is a negative voltage, which is my V plus, minus the negative terminal voltage, which is positive. So this is just going to be negative times my large signal voltage gain. So I'm going to saturate at the negative power supply. So I'm saturated down here. But notice here, right at this point, now the triangle wave has gone above this V minus, and so this blue curve, remember, is V plus over V minus, so that means I'm going to have, at that point, I'm going to saturate up to the positive rail. And then right here, I'm going to come saturate down to the negative rail again. And then we just keep, every time we cross here, we're going to saturate to the different rails. So on and so on. So let's look at another one here, but with the voltage set at a different location. Okay, now let's set this terminal voltage down here instead. So the pot is set so that the voltage on that negative terminal is down here. Now remember, as soon this basically you're using this blue line as a level. As soon as the red curve is above the blue line, we're going to saturate to the high. Whenever the blue curve is below the blue line, whenever the red curve is below the blue line, we're going to saturate to the low voltage. And so what do we get here on an output? Well, we'd start off down like this, but then we'd be all the way up here. Saturate down. Saturate down. And so we can see that this second one we've drawn, adjusting the potentiometer so that the negative terminal is at a lower voltage, gives us something that has a higher duty cycle. And so what we've done here is we've just created a PWM signal. So I just want to kind of go back and look at the circuit here to kind of wrap things up. This first thing was a square wave. This was an integrator. And then this we just use as a comparator. And out of the integrator we got a triangle wave. So pretty slick. Okay, so where we're going to pick up on Monday, to remind you, is that we're going to go over any homework questions. You have a homework assignment due on Wednesday. And then we'll see where we're at. I might talk about this a little bit more. We might do another example or two of RC circuits, but we also then might move into RLC circuits or LC circuits. Alright, so hopefully you guys have had a good week, and I'll see you guys. Maybe I'll see some of you tomorrow. If not, I'll see you on Monday.